Hey everybody, and welcome to this short little lecture on weather versus climate. Now before I get started, if you guys have any questions, concerns, comments, anything like that, just go to this website right here, and that'll give you a little text box to put in your question, comment, or concern, and after you do that, you hit enter and it'll pop up here right on screen. And as soon as it shows up, I will do my best to answer it for you. Now, some of you may be asking, well, why am I doing this? I'm doing this because I want you guys to know what weather is and what climate is, so that you guys can more easily know how they're different, but also how they're pretty similar. And since you gotta start somewhere, we might as well start with weather. Weather is the state of the atmosphere at a current place and a current time with regards to things like heat, how dry it is, how wet it is, amount of sunshine, how windy it is, and things like rain, stuff like that. The thing that's important about weather is that weather can change multiple times during the same day. And if you live in Michigan like I do, you can attest to that because the weather changes pretty much when it feels like it sometimes. And now we'll go over a couple of brief examples of weather. We'll start with the one I believe most people are most familiar with, rain. Now, rain is water falling from the sky in forms of liquid droplets. Now, I know that might sound like duh, but that's an important distinction to make, that it is water falling from the sky in the form of liquid droplets. This is important, because if it's not in the physical state of liquid, then it's not rain. I'll cover a different physical state here in just a minute, but I wanted to make that distinction that it is liquid droplets. Now, a raindrop is formed as when all the little water vapor droplets in the air gather together, or condense, until it forms one big raindrop, big being very relative. It's obviously not this big. This would be terrifying. It's big enough to the point where it's so heavy it can't stay in the air anymore and will fall. Now, in order for this to stay liquid, like I mentioned that it has to be liquid to be considered rain, it has to be warm enough so that the water doesn't freeze. So, rain can only occur if the temperature is above 32 degrees Fahrenheit, or 0 degrees if you're in the Celsius system. And here's just a few brief, quick examples of rain. The soothing, calming, nice rain that a lot of people like, and the ugh, I can't believe I gotta walk home in this rain that not a lot of people like. Well, at least I'm assuming. And now, as I was talking about, here is snow, which is water falling from the sky, but this time in the form of ice crystals. So this is water in the solid form falling from the sky. Now, snow is formed when the water vapor droplets gather together, or condense, but this time they're gathering and condensing around a very, very cold core. This core is cold enough to the point where all the water that gets drawn to it also freezes, hence it making more and more of an ice crystal. And again, this continues until it's too heavy to stay in the cloud. And for water to freeze, it has to be cold enough, so snow occurs at or near temperatures below 32 degrees Fahrenheit or 0 degrees Celsius. And here's a few pictures of snow. We have snow on trees and snow on trees. When I was looking up for pictures to put in for examples, I searched snow and got a lot of snow on trees. But hey, this one's got a dog. This isn't my dog, but I wish it was. It's very adorable. And we'll move on from water falling from the sky to the sky falling from the sky. Tornadoes. Again, we'll start with a very simple definition. A tornado is a rapidly rotating column of air that is in contact with both the surface of the earth, and the sky at the same time. That is very important. That is in contact with both the earth and the sky at the same time. If it's not in contact with either one of those, it's not a tornado. Now, personally, I don't care whether or not it's touching both the air and the sky. If I see a wind funnel, or a tornado, or whatever you're calling it, I'm going to run. Now, tornadoes, luckily, don't form anywhere, or don't form everywhere or any time. They usually can only form in very strong thunderstorms or unusually violent thunderstorms, as some call it. There also has to be sufficient instability, which I'll cover in just a second, and wind shear, which is basically when the wind is rubbing against other wind. Now, instability, if we skip down here just a step, is usually caused when we have warm air, we have air down here, for instance. It warms up and rises, just like warm air would. Well, there's no air down here now, so this becomes a low pressure zone, which then will draw that warm air, eventually will draw it back down as it cools. Well, then it'll warm back up again and go up, and it just keeps doing this cycle. And every time it does the cycle, the wind gains more and more energy. And that will eventually lead towards a tornado. And we have two very different looking pictures of a tornado. This one here, in my opinion, almost looks calm and soothing. It almost looks like a finger poking the ground. Boop. This, on the other hand, looks like a swirling mess of chaos. I almost feel bad for that corn. We'll move on from a swirling air on the land to swirling air on the sea. Hurricanes are not exactly tornadoes over water, but they're very similar. A hurricane is a violent, tropical, basically involving water, cyclonic storm that forms over the ocean and has wind speeds of or in excess of 72 miles an hour or 32 meters per second. Now, this is very similar to how a tornado forms, where warm air rises, except this time down here would be the ocean. It'll rise up, leave low pressure down here, and then as the air up here cools, it'll come back down because of the low pressure and just the fact that cool air sinks, and then it'll go back up, and it'll just continue this until it's a swirling mess of death. And this is what a hurricane looks like from the air, or very high up in the air, and this is what a hurricane looks like from the ground. Next, we'll move on to climate. Now, climate is the atmospheric conditions of an area over a long period of time. And when I say long period of time, I mean long period of time. This isn't something like, oh, the climate's very hot today. Oh, don't worry, the climate will be rainy and cold tomorrow. No, this only changes over a great period of time, as in a desert or a lake turning into a desert. Imagine that as in how long it can take climates to change. Okay, and just to go over a few examples, like I did with weather, we have marine west coast. Now, marine west coasts are known for their mild winters and their cool summers. And that doesn't mean that the summer is cold and the winter is warm. It's talking mild and cool within terms of summer and winter. So it's saying that the summer is cooler than what people think of when you think of the average summer. It's not as warm. Now, mild means it's not as cold than the average winter. It's also, so it's in between. That's what it means when it says mild and cool. It's in regards of the average season. Now, with the marine west coast, temperatures tend to stay in a very specific range, meaning it's really not going to get ungodly hot or ungodly cold beyond this range. Now, I didn't put the range here because, as you can see, there's many different spots where marine west coast happens, so I didn't want to have to put the range in for everywhere. And to get on this map here for a second, the marine west coast climate area is actually these bright green parts of the map, not necessarily the darker green parts. The darker green parts are other versions of the marine climate pattern. So this is just a very good map that shows marine west coast, but it also shows the other kinds of marine climate. Now, one important thing for marine west coast is they have many different types of day-to-day weather patterns, meaning their weather can change pretty rapidly day to day. Here's a quick example of Marine West Coast. A lot of trees. A lot of trees. Don't know what happened to the picture there. Next example will be Mediterranean dry summer. And with a thing that says dry in the title, you might be kind of confused how it says very wet winters. This is kind of with regards to, again, average winters. There's a lot of precipitation that falls during the winter, while their summers are very dry, meaning very little precipitation. This is such an extreme that these areas will get most of their rainfall for the year, up to 70% during the winter months. That means their rain, their snow's not very common, but you get the point. Well over half of it's going to only fall during the winter. Their summers and pretty much every other time of the year is going to be very dry, very, very little water. And you can see here, these are what are some of the Mediterranean dry summer areas. And with a place like Mediterranean dry summer, you would picture a lot of deserts. At least I know I would, and this is what a lot of the areas look like. And the last example I have for climate we're going to go over is subarctic. Called that because it is below the Arctic. So subarctic. It helps me remember it. Hopefully it'll help you guys remember it. Now, the subarctic areas are areas they're more seasonal than most climate areas. And what that means is their seasons are very distinct. Their winters, you're not going to be able to confuse their winter for any time during the winter for any time during their summer. Unlike, places like Michigan where it could be 85 degrees in October and 30 degrees in June. They're very usually kind of set. Their winters are their winters and their summers are their summers. Another interesting thing I found about subarctic is the length of the day. Now, this is not exclusive here. The length of the day will change throughout the year. But this is where it can get very extreme. In the fact that during the winter, their days are much shorter. And in inverse, the days in the summer are much longer. It can get to the point where there's a place in Alaska, for example, that during the summer, there's one day a year where the sun does not set. And inversely in the winter, there's a day where the sun does not rise. Now, around those days, where the sun not rising, the sun not setting, the days or the nights are very long. So that's a pretty distinct distinct feature of these areas, is that their days and nights can be very long. And here's an example picture of the subarctic, where, just to show you that it's not always completely frozen. There is some green in the subarctic. Now, if we were in the Arctic area, it'd look a lot more like the top here. Now here's a quick little graph I made for you guys, just to show the kind of the average rainfall of these different climate areas. Now, this graph might be a little confusing at first, but I'll explain for you guys real quick. This light blue bar here is the low end of their average rainfall. So, for instance, Marine West Coast, their low end ends about here. While the dark blue bar is their high end of rainfall. So, this is about how high it will go. How the high end of how much rain they'll get. So, if you think about it as in the area in between the ends of the two bars, that's about how much rain they get every year. You can see Marine West Coast, they have a very big, a very wide difference on from the low end to the high end. The differences can be very great. Now, the Mediterranean dry summer and subarctic, for example, their difference isn't as great. These numbers can be these numbers aren't as different. So their rain is usually about the same each time. Or not same each time, but it's pretty easy to predict. Now here's a few questions I want you guys to go through at the end here. Just, answer these and then bring them into class next time. I have these questions ready to go when you come into class, so we can talk about them. If you don't have them quite done, that's all.